Welcome back to the Technology Risk Podcast. Before we really get into it today, just a quick reminder, take a second, make sure you're subscribed. You can find us on Spotify, Apple Podcasts, YouTube Music, pretty much wherever you get your podcasts. Definitely don't want you to miss this stuff. Because today, wow, we are talking about that enormous AWS outage, the one that hit US East 1 recently.
Yeah, that was something else.
Right. I mean, everything just seemed to vanish. Fortnite, Alexa, even critical things like banking apps, logistics, just gone for hours.
It really pulled back the curtain on how much relies on these systems, didn't it? Showed the fragility behind that always-on idea.
Exactly. And AWS, I mean, they handle something like a third of the global cloud market. Over 1 million businesses using them. The scale is just immense.
It really is. So what we want to do today is first really dig into how a single software glitch deep inside AWS could cause such widespread paralysis across so many industries.
And then, crucially, pivot to what you can actually do about it. We want to offer some practical, concrete strategies for making sure your company can weather the next inevitable cloud storm.
Okay, so let's dissect the failure itself. The cloud that, well, couldn't. What was the actual root cause here? AWS eventually pointed the finger at something specific, right?
They did, but... Okay, help me understand this. AWS is supposed to be the gold standard hyperscale engineering at its peak. How does something they called, I think, relatively mundane lead to hours of global downtime?
Yeah, it sounds counterintuitive, doesn't it? But it wasn't some massive external attack or a power grid collapse. The core issue was actually a bug deep inside their own automation and DNS infrastructure.
Internal systems, okay.
Right. And the really critical part, it was triggered during what should have been a routine system update. So it wasn't just one server crashing. This bug set off, well, a chain reaction, cascading failures across all sorts of dependent systems.
Okay, DNS. We hear that term a lot. It's like the internet's phone book, people say. But this was internal DNS inside AWS. What happens when that breaks?
That's the key distinction. When AWS's internal phone book fails, their own services can't find each other. Imagine your company's sales system trying to talk to its database.
Right.
If the internal DNS is down, it literally can't find the database's address. It's like the system goes blind internally. And these automation systems trying to fix things or update things just started failing everywhere because they couldn't resolve these internal addresses.
And that's not a rare occurrence. You mentioned a statistic.
Yeah, it's surprisingly common. DNS failures, broadly speaking, account for something like 28% of major cloud outages. It's a recurring weak point.
Okay, that highlights the systemic vulnerability. But still, why US East 1? Why did one region cause such a global headache? Isn't the cloud meant to be distributed? Redundant.
But US East 1 isn't just any region. It's the oldest, the biggest, arguably the most critical hub in the entire AWS network. Think of it like, I don't know, the central switching station. Estimates, like from Cloudflare Radar, suggest it handles maybe 35% of all AWS traffic. And lots of companies, even if their main application runs elsewhere, might use US East 1 for fundamental things like logging in, like identity management.
So core services are centralized there for many users.
Exactly. So when that central hub stumbles, the shockwaves go everywhere, even if your app is technically hosted in, say, Europe or Asia Pacific.
And the impact we saw, it was broad. Obviously, the consumer stuff got the headlines, Fortnite, Netflix, Alexa going quiet. But what about businesses? What were they experiencing?
Oh, it was brutal for enterprises. Banking platforms, supply chain tools, healthcare systems, anything relying on those AWS APIs, those connections just stopped.
Ground to a halt.
Completely. We saw reports, for instance, from a major U.S. financial app. They were down for over 6 hours. 6 hours. Think about the lost transactions just in that window.
Millions.
Easily. Millions. And that's the scary part. A software bug, probably in a data center in Virginia, caused tangible multi-million-dollar damage worldwide.
That really sets up the next part of our discussion perfectly. The hidden risks, the systemic vulnerabilities, this whole mess exposed. We moved to the cloud thinking we'd avoid single points of failure.
And instead, we've kind of just consolidated the risk into, what, 3 main players? AWS, Azure, Google Cloud?
Right. Vendor concentration risk. That's the term.
Absolutely. And the stats back it up. Something like 79% of companies rely mostly on just one of those big providers for their absolutely critical applications. Your entire business operation hinges on that one vendor staying up.
That is worrying. And I know we've discussed this idea of the multi-cloud illusion before. Companies say, oh, we use multiple clouds, but dig deeper.
And you find out their core database or their identity system, maybe their primary storage, it's all still sitting back on AWS, usually US East 1.
So if that core piece fails, the rest of their multi-cloud setup doesn't matter much.
It's like having two different brands of car, but they both need the exact same single-source proprietary fuel. If the only gas station selling that fuel closes, well, having two cars doesn't help you, does it?
Good analogy. So multi-cloud has to be truly diversified at the core service level to actually provide resilience.
Intentional design, that's the key.
And the irony baked into all of this is automation. The very systems designed to make the cloud more reliable, self-healing, they became the trigger.
That's perhaps the biggest lesson here. The real danger isn't just that the cloud can fail. It's that the automation meant to prevent failure can actually amplify a small human error or bug to global scale instantly.
It's not carefully managed.
Exactly. Over-automation without robust checks, without human oversight, without those safety valves, it actually increases risk instead of reducing it.
And those safety valves.
Yeah.
You're talking about things like circuit breakers in the software, right? Can you explain that a bit?
Yeah, precisely. A software circuit breaker is basically a safety switch. Imagine an automated update starts causing problems. Maybe it's deleting data or crashing services. The circuit breaker detects this abnormal behavior, like too many errors happening too quickly, and it trips. It stops that runaway automated process before it can take down the entire system.
So it contains the blast radius.
It contains the blast radius.
Yeah.
Without them, a small coding mistake during an update can just keep spreading and scaling until everything grinds to a halt.
This whole event really does shatter that old myth of cloud resilience, doesn't it? That idea that the cloud never goes down.
It was never really true, but this made it impossible to ignore. The data shows major cloud providers now average, maybe 4 significant outages per year, each one affecting potentially millions.
4 a year? That's not a rare event anymore.
Not at all. It's becoming a regular operational risk, something businesses absolutely have to plan for, not just hope against.
Which leads us straight into the business fallout. Let's talk dollars and cents and maybe reputation too. What did these hours of downtime actually cost people?
The numbers get eye-watering fast. Gartner has that famous figure. Average downtime for critical applications costs around $9,000 per minute.
Per minute?
Per minute. So if you were down for, say, 6 hours, like that financial app, you're looking at over $3.2 million in direct operational costs. And that's just for one critical system.
Wow. It's almost hard to process. $9,000 every 60 seconds. Gone. Just because of a software issue somewhere else.
And it hits everyone differently, right? E-commerce sites lose sales directly. Financial services have failed trays, angry customers. Healthcare might lose access to patient records or scheduling, which, can have serious consequences beyond just money.
And the really painful part for businesses listening, their customers aren't blaming AWS. They're blaming your app, your service for being down.
Absolutely. The reputational hit can be huge and last much longer than the outage itself. We saw data suggesting a SaaS company lost about 12% in customer trust scores after they had repeated cloud issues.
Ouch. And silence makes it worse, doesn't it?
Oh, definitely. Vague updates or just going quiet, that erodes trust faster than anything. People understand things break, but they hate being left in the dark.
Beyond trust, what about the regulators? We saw mentions of SLA breaches, IAPA, GDPR. That sounds serious.
It is. This isn't just about inconvenience, it's about compliance. For finance, for healthcare, these outages can mean breaking legally binding service-level agreements with your customers. Or worse, you could fall foul of data regulations like HUPO or GDPR regarding availability. The potential fines there could easily dwarf the direct downtime costs.
So cloud uptime isn't just an operational goal, it's often a regulatory requirement.
You have to treat it that way, yes.
Okay, this brings us to the crucial part. What can we actually do? Engineering resilience. The big takeaway seems to be you can't just assume resilience, you have to actively build it. We've pulled out 5 key strategies from the analysis.
Right, and the first one is foundational, designed for multi-region redundancy. If you're all in on AWS, you absolutely need critical workloads running in more than one physical region. Even better, spread key functions across AWS and another major cloud provider, true multi-cloud.
Okay, so spread the risk geographically and maybe even across vendors. What's next? Because just setting it up isn't enough, right?
Not at all. Step 2 is test your failover scenarios regularly. You have to actually practice failing over. Simulate an outage in one region, see if your traffic automatically reroutes, see how long it takes, what breaks.
Makes sense, like a fire drill for your infrastructure.
Exactly. And the data supports it. Companies that do regular testing cut their average outage duration by something like 65%. It makes a huge difference when the real thing hits.
Okay, number 3 takes us back to the cause of this mess.
Monitor those automation layers, put in the checks, implement those circuit breakers we talked about, especially for any automation that touches critical things like updates or DNS configuration. You need safety nets for your safety nets.
Got it. Number 4 is about not putting all your eggs in one basket, even within the cloud.
Diversify critical dependencies. Think about essential services. DNS resolution, maybe your primary data storage, your identity management. Don't have all of those reliant on a single vendor or even a single service within that vendor. Spread them out. If your DNS provider goes down, can your app still function using cache data, for example?
Prevents that single point of failure from causing a total collapse. Okay, and the 5th one is less technical, more communication.
Absolutely critical, though. Communicate transparently during downtime. Be honest. Be proactive. Tell customers what you know, what you're doing, even if the update is just, we're still investigating, here's the latest. Silence is deadly for trust.
Those 5 steps seem really practical, and we saw examples of companies that did this right and wrong during the outage, didn't we?
We did. There was a gaming platform, for instance. They were using both AWS and Google Cloud, and crucially, they had built and tested active failover between them.
So what happened when US East 1 failed?
Their systems automatically detected the AWS failure and rerouted player traffic over to Google Cloud. Users barely noticed, maybe a little lag spike, but the game stayed online. It proves multi-cloud resilience works, but only if it's intentional and practiced.
And the flip side, the cautionary tale.
That was a fintech startup. Heavily reliant on AWS, all in US East 1, no real failover plan tested. Result, 6 straight hours of complete outage, huge revenue loss, customer anger, the works.
The lesson there seems pretty stark. Uptime isn't guaranteed by the cloud provider. Resilience is something you have to invest in yourself.
Precisely. You have to budget for it, engineer for it, test it.
So looking ahead, what's the mindset shift needed? How do we future-proof?
I think first, you need to start treating your cloud vendors as part of your overall business risk portfolio. They sit alongside things like cybersecurity threats, natural disasters, supply chain issues. They are a risk concentration you need to manage.
That makes sense. And maybe think differently about failure modes.
Yeah, designed to fail gracefully. Instead of your entire service just bricking itself when one dependency like AWS has an issue, can you maintain partial functionality? Maybe users can still view existing data even if they can't update it, or access basic features.
Partial service is way better than no service.
Always. And finally, keep pushing the vendors. Demand more transparency, clearer service level agreements, understand the shared responsibility model better. Don't just accept the marketing hype.
So let's wrap this up. The big picture from this AWS chaos.
It really shattered that illusion of infinite cloud uptime, didn't it? Showed how one bug, one automation failure in one critical region could send ripples across the globe, affecting millions.
But the core message isn't abandon the cloud.
No, not at all. Cloud is essential. The message is reliance without resilience planning is the real danger. You have to assume failures will happen, audit your dependencies, and actively engineer for multi-region, maybe multi-cloud resilience before the next big one hits. Because it will.
Assume failure, plan for resilience.
That's the mantra, and maybe the final thought to leave people with.
Yeah.
The internet, for all its distributed nature, is perhaps far more centralized than we like to think. When one of these massive clouds stumbles, the tremor is felt almost everywhere. It shows how interconnected and maybe how fragile the whole digital ecosystem really is.
Yeah, that is definitely something to chew on. A sobering reminder of the foundations we're building on. All right, that's our time for today. Remember to hit subscribe on Spotify, Apple Podcasts, YouTube Music, wherever you listen, so you catch our next discussion. We appreciate you tuning in. We'll see you next time on the Technology Risk Podcast.